Let's do it. I think we're live. If we're live and you're in the chat, go ahead and drop a GM. Let me know you're here, and we'll get started here in just a moment. Go ahead and start a little countdown here before things get going. All right, we got a couple of y'all in the chat. Good to see you. What's up, Alex? And sorry if I butcher names, but Adewale? Good to see you in the chat. We are going to walk through building a NFT-based Web3 game. And the reason I say game is because we're going to build a Tamagotchi that is 100% blockchain based. All of the assets, everything about this Tamagotchi is going to be on the blockchain. So what's it going to look like? Let's take a look real quick and see what we're going to be building. So we're going to be building a pretty simple web app that's going to give us access to our Emojigachi, because Tamagotchi is probably TM, and we wouldn't want to mess with any of that. So we've got this Emojigachi here, and as he gets hungrier and more bored, well, he's going to get less happy. But we can feed him, and it's going to be all on chain. So when we feed him, it does cost a little bit of gas. We'll be deploying to the Mumbai test network. That's Polygon's test network. And you'll see it takes just a minute here, but you'll see we fed him, so he's not going to be hungry after just a moment. And while we wait for that to come in, let's talk about where you can find the starter for this project. On my GitHub, I'll go ahead and throw this in the chat again. You can get kind of like the base for this. It's broken into 3 different branches. So starting out, we'll be here at the main branch. And then once we've built the contract out, Foundry, this branch has all of the changes for the actual contract. And then finally, we're going to use Foundry and SvelteKit to build out this full application. So if you want to follow along, feel free to, or just feel free to sit back and watch me try to type correctly. When we get to final, that's going to be the final version. It's going to be what is deployed here. You can see we fed him. His hunger's not at 100 right now. It's already down to 90. And his enrichment or his boredom level is also down to 40. And that's happening on its own. And that's another thing about this project is we're going to use Chainlink keepers to automate our Emojigachi so that time will pass and he'll get hungrier and more bored as time passes. We can just bump him back up to 100 real quick on both of these so you can see him change into a very happy little emoji. And we'll see if it works out that as we're doing this, things might get kind of dire for this emoji. So we'll keep our fingers crossed that he survives. But I think it's going to be a fun project. So yeah, do we want to, how are y'all feeling about it? Do you want to try to code along or do you want to just watch? I'll wait for y'all to pop some answers in the chat there. That'll kind of determine how quickly I go. This will be recorded. So after this presentation, you can go back and rewatch and play along. What's up, Tippy, Leo, Shaman? Got a bunch of people in the chat. How's it going? We're going to watch. Okay. So let's go ahead and dive right in. I'm going to be using Foundry. Foundry is a pretty new framework for smart contract development. I really like it because 2 reasons. One, it is fast. Like when you run the tests, it screams. It's amazing. It's so much faster than what I've seen with Hardhat or Truffle. Second, the tests are written in Solidity. And I really, really like the fact that I don't have to do this weird switching in my brain between, okay, so I'm writing some code and then it's test, because I like to do test-driven development. So I'm writing my test, and that's like in JavaScript Mocha land. And then I switch over into, okay, now I'm doing Solidity again, and now I'm going to like make that test pass, right? Foundry's awesome for that. I'm also going to use SvelteKit. I personally love SvelteKit. It's pretty easy to explain what's going on. There's a little bit of Svelte magic that happens. We'll get into that. But overall, it's pretty simple and straightforward as a place to start, in my opinion. And I don't know, I just like it. It's clean and easy. So we're going to use both of these tools to build out our Emojigachi. He's pretty happy right now. Okay, so let's dive in. I'm also going to be using VS Code for this. There's a couple of things with VS Code. You may notice I have two windows open. In that GitHub repo, it's kind of like a mono repo in that there's two folders in there. There's a Foundry folder and a Svelte folder. And I've put a little bit of VS Code magic in both of them just to differentiate the workbench title bar here so I know which window I'm in. Feel free to steal that for any projects in the future. I think it's great. The other couple of things that I've set up, just so we know where we are as far as starting place. There's a deploy script. This is going to let us actually deploy our contract to Mumbai. And all this is doing, it's a fancy way of reading in variables without displaying what you're typing in on the command line. That way I can just type it out. Y'all can follow along, but you won't see things like my API key or my private key when it goes to deploy it. There's this remappings file. What this does is it lets you use things like Open Zeppelin contracts and import them in the way that you would expect if you were doing something like using Remix or Hardhat, where you just import at Open Zeppelin / whatever the contracts are that you're importing. So that's awesome. This just kind of lets you do that, remaps it to the lib directory. And that lib directory is actually where I've gone ahead and installed the Open Zeppelin contracts using Forge. Forge is the one of the commands within Foundry. Within lib2, there's also this test, and that's going to be the testing framework that comes with Foundry. To the question, all of this can be done in Hardhat, right? Yes, except the testing would look different. So that's something just kind of to keep in mind. The concept behind the tests would be the same. How you actually go about running those tests, that'll be different. And test-driven development together, absolutely. Test-driven development, it's the best way. It takes longer, but you know everything works. Cool. So we've got our emoji. Let's take a look at that emoji again real quick and see here. We've got a few things here to think about, right? We have this cool image. It's an SVG. It's stored on chain. We've got a couple of different values. We've got his hunger, enrichment, happiness. We've got two different things we can do. We can feed him and play with him. So let's start creating our tests. I think that's probably the best place to start. Looking within Foundry, we have our source directory. And inside source, we have a couple of things they provide us. They provide us with the world's most amazing and complete contract that does nothing, but it's awesome as a, just kind of holder to show you where stuff goes. And then we have a super thorough test that says, is true true? And yeah, that's it. That's what they give you. So what happens if we run Forge test? So Forge, again, is the command to run things within Foundry, or one of the commands. We run this, it compiles our contract, and it runs our test, and we see that our test passed. Sweet. So we know that we have Foundry installed. We know that the Forge test command is working. From here, we can go ahead and add a new file. So let's go ahead and add emojigachi.t.sol. That .t means it's a test. And in true expert developer fashion, I'm going to use this amazing shortcut, Command C, Control C if you're on Windows, and then Command V. So I'll go ahead and grab this basic test as a place to start. This contract, it's Emojigachi test. And then we're importing this DS test. That's the testing framework. Tippy asks, do we have to install something to get Forge working? Yes. So you'll need to install Foundry. If we go back here, we look at installation on the Foundry book. Here, you can see the instructions for installing Foundry, and then you'll need to run Foundry up. And then it walks you through first steps. This init is essentially where we were, except for we installed those open Zeppelin contracts as well. Missing H in the name. Thanks for calling it out. You're going to be busy, Charlie. You're going to be busy with my typos. Cool. So we've got our test. This test doesn't actually grab anything yet, though. So if we go ahead and run, save this and run our test again, you'll see we now have 2 test examples. And that's great. So our test is running. We don't have a contract yet, though. So I'm going to go ahead and clean a few things up. I'm going to delete, actually, I'll leave that one for now. I'm going to delete this test, though. So we just have our 1 test case here. And now we need to go ahead and create the base for our contract. So we'll call this Emojigachi.sol. And again, Emojigachi here. We created our basic contract here. We've got our test. We need to import our contract into this so that we can start testing our actual contract. But before we do that, let's take a moment and think about, again, our emoji and kind of just stub out what we need to do. So we've got this setup. This setup is going to be run before every single test. So within here, we want to do things like we want to go ahead and mint. We need to also create an address just to make sure that we know what address we have for that. And we'll also need to, before we mint, we're going to need to assign the contract object to a value. So see what that means here in just a second. Then things that we want to test. Just going to run through real quick what I think would be good tests when we think about this. So the first thing we want to do is our emoji is based on an NFT. So we're going to need to mint the NFT and make sure that works. Then we're going to want to make sure that the URI is correct for the NFT. The URI is kind of the data behind it. Tippy's asking, is installing the same as building from source? I don't think it would. If the install works, it'll probably be faster. Building from source will take more time, most likely. We've got the URI. Then if we think about our emoji and the fact that things are decreasing, in my mind, that's time passing. So we're going to want to test passing time. I'm just kind of stubbing out the different tests that we need to think about as we go through this. I don't want to miss something. We can feed the emoji. We can play with the emoji. The image, we need to make sure the image changes. So that SVG. Then I mentioned that we need to have Chainlink keepers be enabled. So Chainlink keepers require 2 functions. One is called check upkeep, and the other one is called perform upkeep. So we'll check that both of those are there, and we'll check that they're both working. So this should just be perform upkeep. Sweet, Tippy, you got it going. Tippy chose the play along option. it seems. Cool. So these are the tests that we're going to need, right? We have our basic emoji contract here, and I'm going to do a little bit of movie magic in that I'm going to paste in what is essentially the Open Zeppelin basic ERC 721 contract. If you head to Open Zeppelin, oh no, this is getting bad. He's down to 40. If you head to Open Zeppelin and you take a look at their docs, they, under contracts, have a wizard. This wizard lets you just like click and creates the basic skeleton contract for you. I love it. So we've got a contract for an ERC 721 token. We can make it mintable with IDs. We're going to need that URI storage. Like you can just copy and paste this. They did change it a little bit since I went through it the first time with this. So that's why I'm not just copying and pasting right from here. They've added a few little security features, which are really good. But if mine looks slightly different than this one, it's because I grabbed it probably earlier in the week. So it seems like they've changed this just recently. To be asked if I'm loving GitHub Copilot. Most of the time, I'm loving GitHub Copilot. Sometimes Copilot seems like it's drunk and needs to go home. You'll probably see some of that today. But mostly, Copilot is amazing. I'm a fan. If you notice as I type, there'll be some gray text sometimes. If I hit tab, it'll autocomplete for me. That's GitHub Copilot. So we've got our basic contract created here. Just to walk through this super fast, it's called Emojigachi. It's an ERC 721. We're importing two different contracts, one for that URI storage. This one also imports the Open Zeppelin, just plain ERC 721 contract. We're also grabbing counters. If you'll notice this import at Open Zeppelin, that's what I was mentioning here. That's what this remappings is doing. So we just have our counters. That's going to give us a token ID, our constructor, which does basically nothing. We have our mint operation, a burn, and a token URI. So this is all super basic standard skeleton. It's a boring ERC 721. We can't play with it. It's not fun. No pictures, but we'll fix that here in just a second. Sweet. So we've got our contract saved. We need to import our contract. Lost you at remappings. Remappings is a Foundry file that essentially is saying when we're compiling, if you see this, then it's going to actually point to lib Open Zeppelin contracts. So that's where Foundry is going to keep it. So under lib, we have Open Zeppelin contracts and DS test. And the skeleton is going to be in the main branch. So main is the starting point. Foundry will be the done with the contract. So if you head to the GitHub, Foundry has all the contracts and everything in here that you would need. So this is kind of the completed version. Cool. Thanks for the clarification, Freddie. Yeah. All right. So we've got our remappings. We've got our imports. We need to actually import in our contract, right? So we've got our basic ERC 721 contract. I guess I'm kind of already breaking the rules of test-driven development because I didn't write the test for this first, but I just wanted that file to be there before we got going. So let's go ahead and import it. Slash Emojigachi.sol. So this will import that contract so that we can then use it. And we'll need to actually set up that contract, let this know about it. So it's Emojigachi, and then public, and we'll just call this EG. Emojigachi. And then within our setup, right, we said we wanted to do a few things. So this is to be run before every single test. We'll be running this. Oh no, Tippy, I'm sorry. It doesn't have the copy pasta contract. Let me Let me throw that up real quick. Take a brief interlude, y'all. I'll get this on a gist. This is it? Yeah, this is it. Okay. Here you go. Copy and paste to your heart's content. Thanks for pointing that out, Tippy. So our setup function, we want to do a few things, right? We need to first declare a variable to assign the contract. So we'll call it EG and say it's a new Emojigachi. And then we want to create an address to make sure that we can check the minting process. So this is where, like, I don't know, the Copilot stuff is kind of amazing because I say 0x and it'll go ahead and fill it in the right length. If I start typing 1, 2, we can just get an awesome address like that. And then we'll call SafeMint for that address. Essentially what this will do is it will say we're going to create a new instance of the contract, create an address, and then we're going to mint an NFT to that address. So this runs before every single test, but we need a test to run first. We get rid of this is true because we know that true is true. So, we're in the correct version of the multiverse where true is true. Our tests will work. And we'll call this function test mint. Again, this is something that I love about Foundry. I'm writing Solidity to write my tests. So we test the mint. Again, we're going to assign the address. And we're going to create another address and we're going to assign it to the same thing. Why are we doing this? Well, we're going to check that the address of the owner is equal to the owner of 0. What is this doing? We're minting up here, and then we're checking to see, we know that this is going to be the first instance of the NFT. So that's what this is. This is going to be the token ID. So we're going to check and see, is the address that we expect it to be the same as the owner of 0? So this 1 verifies that we actually minted an NFT. 2 verifies that SafeMint is working and assigning the owner to the address that's passed in when we mint. Normally this would be message.sender if you were minting it yourself. And then this is a little bit of Foundry magic. See, here's where it's like, go home, Copilot. I don't know what you're talking about. That is not Solidity. So we're going to do assert EQ, address and owner. What's this? Assert EQ. Where'd this come from? It's in DS test. If we, yeah, Tippy, GitHub Copilot is amazing. I have to think it's pulling some of this from the examples I have up there because like it starts to fill out exactly what I want as we go through this. So DS test, I'm going back to the Foundry documentation. We have this DS test reference. This is all of the functions that are built into DS test. So we have logging. We have asserts to say, are things true? Are they equal? Are they equal decimals? Are they, all the different types? Greater than, less than. So these are all the different tests that you can run with DS test via Foundry and just stay right here in Solidity. So let's go ahead and run our test. Again, got to save. Always got to make sure if you see that little dot up there, it means you haven't saved. So run our test again. Oh no. Man, we got that typo game going on. Owner of, maybe. Sweet. We've got our test mint running. Awesome. We can know now that our contract will mint NFTs. They're not very interesting NFTs yet, but we've got that. Thanks, Shaman. Yeah, the typos, man. The typo game is strong today. So from here, we need to think about the URI. And maybe this is poor form when it comes to test-driven development, but this is going to be a big one. And in my mind, it's only testing one thing, but it tests a lot. So let's create our test function, and we'll call it test URI, and it'll be public. And from here, our Emojigachi is going to have a few things. It's going to have happiness. It's going to have hunger. It's going to have enrichment. It's also going to have not cleanliness and socialness. It's also going to have a time that was checked and an image, right? The reason we need the time that it was checked, just kind of thinking ahead to enabling it to be automated with keepers, is that we need to know when the last time passed, basically. So the last time it was triggered via that keeper contract. Speaking of keepers, I've got a really bad feeling about our emoji. Y'all, it's been a little bit. Oh no. Oh no. Our emoji's dead. But it's okay. Emojis are tough and resilient. We can bring them back to life. With just a little bit of gas fee, we can bring him back to life. It'll be okay. It'll be okay, little buddy. Okay, so we'll go back here and think about the fact that we need all of these things to come in. Like I said, this is a big test, man. So we'll need something to get them. I think I'll call it Gachi stats. So eg.gachi stats. This will give us the stats for a specific Emojigachi, and we'll need to pass in the token ID. Okay, this right here would be an amazing idea if like it had died. We could make this more interesting, and like if it's died once, then all the faces are going to be like zombie phases. That would be amazing. We're not going to do that, but like it's a good idea. I like it. So we're going to grab the stats. It's going to have all of these different values. So let's go ahead and put them in here. So we're going to have a uint of happiness. And then let's see if we can get Copilot to be amazing. Maybe. There we go. Look at that. Hunger enrichment checked. And it even knows that the image is going to be a string. I think we need memory there. But it's so close, y'all. Man, this stuff is amazing. It's gonna like put me out of a job here. Once it starts explaining stuff, I'm done. Okay, so we have uint 56, happiness, hunger, enrichment, the last time it was checked, and the image. Those are all gonna come from a new function we need to build called Gachi stats. Sweet. We get those values. We need to test them, right? And we could break these out into individual tests, I guess. That'd probably be a little more proper way to do this, but we can do massive test-driven development. So we're going to assert equal, and I don't know why GitHub Copilot always does this. It wants to assume that things start at 0, so our emoji's not happy. Strings, you have to declare where they're stored. So if you leave it like this, I think we'll see an error here in just a moment. So you need to tell it where to store it, Pascal. So we'll just store it in memory. So we need to assert equal, and we'll start with happiness. So happiness, when things first start off, should be 100. But really, what I think happiness is it's your hunger plus your enrichment. Nope, Copilot, go home. Divided by 2. So it's just the average of your current hunger score and your enrichment, or how bored you are. We also need to assert equal that hunger should be 100. Maybe this is backwards. In my mind, I think things start at 100 when we're looking at these bars, and then they go down. So maybe that's backwards. I don't know. That's just how I'm running with it. Assert equal. And we want to say that our enrichment is also 100, because when we initialize this, everything is amazing for an emoji. So we have hunger enrichment, assert, equal, and checked. And this is going to be equal to the block.timestamp. So that's going to be the timestamp of the block. So that'll be when we checked it. And then I'm going to deal with this in another test because the image is interesting since we're doing it on chain. You could do it with something like IPFS and put it out on IPFS and just link off to that URL. But we're actually going to use an SVG on chain. So like everything lives on chain. So I'm just going to take this out. One thing to know, this function, we want it to still return that value. So we're going to leave a hanging comma here. In JavaScript, you might have something like this, like an underscore for an unassigned value. You just leave it empty with just a comma. It's weird. It's Solidity. I don't know. So we've got that. We've got all our tests. Let's go to my favorite part, failing as expected. Yep, failing as expected. We don't have a Gachi stats function yet. Do with IPFS for access to another bounty boys. Oh, pro tips from Tippy. If you want to do it with IPFS, you're welcome to. It'll make it a little bit easier, probably, but I don't know. I'm a fan of fully on-chain stuff. Nothing wrong with IPFS though. Okay. Before we go any further though, let's talk about this SVG. So I have an SVG. It looks something like this. All in one line is terrible. Let's format this. Okay, still pretty terrible. SVG is kind of like XML. I guess essentially is XML. So what this does is it has this gradient. If you look at the emoji, that's going to be the background. And then, we've got our rectangle and we fill it in. Cool. And then we have this bit here. It's just some text. And you'll notice this text has an emoji in it. This is where the emoji comes from. I'm not sure where you're seeing this error from Tippy, sorry. So this is our SVG. Now, Open Zeppelin, in their contracts, has a utility contract called base64. This will base64 encode your SVG. You can use this if you want to do that. If you had something that you wanted to base64 encode, I'm going to go ahead and pre-encode the SVGs and just hard code those values into the contract. So what does that look like? Let's go ahead and grab another little thing here. It looks something like this. I know all of this is amazing. It's beautiful. That is that SVG, base64 encoded. I've added in this little bit here, data telling it there's an image, what type it is, and that it's encoded. And the last thing to know about this is we have these ending strings. So when we look at this SVG, we're going to be changing this value, right? That's going to give us this emoji right here. Well, when all of this is encoded, essentially these three characters are going to be your emoji. This is just something I noticed when I was looking at the different encoded values and trying to figure out how I could maybe make this whole thing a little bit more efficient to mint and update. So instead of having to re-encode the whole SVG every time, I've just pre-done it. And if you notice, these three characters are essentially that emoji. So how can we take a look and check this out? If we take this value, add it to the end of that massive base64 encoded string, and then we do something truly insane, like paste it into our browser right there in the URL bar and hit enter, the browser will render that SVG out based on the fact that it's base64 encoded. So this is how you can take an SVG, encode it, store it on the blockchain in your NFT, and then your browser knows how to render it because it can render that data out. I think that's pretty cool. We mentioned those 3 characters being what determines it. So if we take, let's see here, we're looking for WVD when we go back into the URL bar. If we head here and we look for WVD, we'll take these 3 characters, replace them, and our emoji changes. So this is how we're going to take our SVG, take our image, and store it on the blockchain. I don't know. I think that's pretty sweet. Again, remember, evidently, there can be an extra bounty if you use IPFS. So you may want to do that. You can totally take these SVGs and store them there too. So the error you're supposed to be getting, let me just pop that back up on the screen for those of you following along. Yep. It basically can't find this function in our contract because we haven't created it yet. This the guy leading this workshop has just been blabbing on and on about SVGs instead of writing contracts. I don't know. But we have our data for the SVG and we have the different states, right? So just so you're aware, this is like that starry-eyed one. This is a really happy one. This is a not so happy one. This is the angry guy. And this is the dead one. So yeah. All right. We've got these. We need to get this and get back to actually writing our contract. So we don't need to save our SVG. I guess let me go ahead and just add these values. They're in the Foundry branch of this, but I'll go ahead and add them to that gist real quick. So that same link should still work, SVGs. And then I'm going to just pop those in there. And if you're following along and you need that link again, because scrolling is hard and I am lazy, so I will give it to you. There you go. Okay, back to Solidity. So we have our test. We want to check our happiness, our hunger, our enrichment, and the last time it was checked. All of this talk about SVGs, and we're not even going to use them right now, but just tuck it in the back of your mind. We'll get to them really soon. Whew. Okay. So we need to, well, let's go ahead and let's add them to it while we're thinking about it. Let's just go ahead and create a couple of variables to hold these things. And did I add that to the very end? Let me make sure I don't leave that on here. Yeah. Because then that'll ruin everything. Yeah, I think this plus shouldn't be here. That's what we need. Okay. Let me update that gist. Did it bad. And it shouldn't have. Let me double check real quick. We basically had the emoji already on the end and we don't want that. Yeah, sweet. Okay. So if you grabbed, copied and pasted from the gist, my pronunciation of that word is terrible. I think GitHub, and so I say gist or gist. I don't know. It's a GIF. Anyway, if you grabbed it from there, you may need to grab that again. Cool. So we grab these. We go back to our contract. Let's create a couple of values here. So the first thing we need is the string that's going to be the SVG base. And we'll just paste this in real quick. So this string, oops, not that one, a single tick, is going to be the base, right? And then we have these other values here. Pilot is drunk. And we'll call this is going to be an array of strings. And I don't know, we should call these probably, let's call this emoji base 64 equals, and then it's going to be an array Cool. And save. Maybe put that in there. Save. All right. Oh, we need our semicolon at the end here, y'all. Save and hey, formatting. It's beautiful. Okay, so we created two new variables. The first is the string for the base of the SVG. So this is gonna be like the front part. And then the latter part is gonna be what changes based on the current status. Cool. Now we need to set up all of these different stats inside the values here. So Shaman, you don't need memory here. I think it's because we're not reading it, we're setting it. And so we don't need to know where it's going to be in the same way. I'm sorry, I am not Solidity fluent enough to easily explain that, but you don't need it there. The SVG string looks like an ABI. I mean, it's encoded, yeah, kind of, but we're telling it what it is up here. So we've got these two values. Now we need to change some things in our, I think maybe two, Shaman, it has something to do with the fact that these are like global variables and not being called within a function. I'm honestly not sure. So I just know it will error out if you don't have it some places and not others right now. Okay, so within the mint function, we need to do some things with this token URI. We also need to create some sort of way to map our tokens to all of these different attributes. So when I think about that, I think our Emojigachi is going to have attributes, and that's going to be kind of contained within a struct. A struct is kind of like defining an object. So our Gachi attributes here is going to be a struct. This is going to have the uint for the index. It's going to have a uint for the happiness. Yeah, let's go, Copilot. Hunger, enrichment, checked. I'm going to call this last checked. So close. And then a string for the image URI. Yeah, URI. Cool. This will kind of define our Gachi attributes. We also need to think about so Tippy, it's going to like when I save, it formats it to uint 256. You don't have to. They're the same thing, I believe, at this point. We can make them constants if we want. I'll leave that up to y'all. If y'all want to make them constants, because they're not going to be changing, you can do that as an optimization. Sure. Answering Pascal's question. Cool. So we've got our attributes here. We also need to map, while in this walkthrough, it's only going to be me minting. We need to map our Gachi holders, the people who have these NFTs, from an address to the index that applies to them. So we can keep track of when I make a request, I know which index I'm talking about. So we'll make a mapping for that of an address to a uint. And then this is going to be, we'll call this Gachi holders. And we also need a mapping for the Gachi attributes. Yeah, like that'll work, right? We'll call this Gachi holder attributes, though. I like that a little better. So we're mapping from the index then to the Gachi attributes, and we'll call that Gachi holders. Cool. We've got our, okay, Tippy. I mean, It's close, right? It's pretty good. I don't know. We don't want it to be perfect because then we're out of jobs. Um, cool. So we can map now and keep track of who has which Emojigachi and then what the attributes are of that Emojigachi. Cool. So back to our mint. And I'm bouncing around a little bit. Hopefully it's not too much and we're on the same track here. All right. So we have our token ID. That'll be good. We increment it. Cool. When we actually create this thing. So we assign it to that and then we increment it. So we're going to need the final SVG. This will be what we actually insert in. So it's going to be a combination of the SVG base and then the emoji that's encoded as well. So it's not going to be just a string like that. We're going to say it's a string and we need to combine those two strings. So we'll take the SVG base to combine. Sorry, we do ABI and we encode packed. And then we'll take the SVG base. I think that's what I called it. Yeah, SVG base. And we'll combine that with the emoji base 64. And we'll just start off with a 0. That's 2 closing brackets. Give that a save. I'm going to get rid of these files so we just have a little more space. Cool. So that'll give us our final SVG. And then we will create the Gachi attributes for the token ID. So Gachi holder attributes, the attributes for the token ID are going to be, we don't need new here. Oops. So we have our attributes and this is going to be that object. And we're going to set the Gachi index to the token ID. Hey, Dana, we are using Foundry to do all this. If you want to just follow along with the actual contract and not the testing piece, you could 100% do it in Remix. And you could deploy it from Remix and then come back to VS Code for the actual front end piece of things. So we've got the index. What else did we need to set in here? The index, the hunger, happiness, hunger, enrichment, last checked, and image URI. So we have the happiness. I'll set to 100, hunger to 100, enrichment to 100. Call it last checked, right? Last checked. The timestamp, and then the image to final SVG. That looks good to me. Right, we got everything we need in there, I think. And at this point too, we'll need to assign the Gachi holders for this, not the token ID, message.sender. So whoever mints this, they're going to be the Gachi holder. Well, cool. Let's take a look at our test again. So at this point, we still haven't created our Gachi stats test, have we? No, we haven't. We're just updating all the stuff for minting. Whew, I told y'all, this is going to be a doozy. Do we want to go ahead and jump into the token URI? I think we should. And I'm going to warn you now, the token URI is probably the hardest part. It's easy, but you'll see why I say it's the hardest part. So we have our token URI. This is going to be what contains the JSON blob, if you will, that informs the information about the emoji. So if you were to head to OpenSea and take a look, like all the things like the image, the description, all that stuff that OpenSea pulls, that's coming from the token URI. And yeah, it's going to be a doozy. So let's talk about it. The first thing that we're going to do is we're going to get rid of this return. And then we need to get the Gachi holder attributes for our token. Whew. Yes, it's going to be all the metadata. It's going to be like this JSON blob that is formatting. This is the hard part, and you'll see why in just a minute. So we need our Gachi attributes, and these are going to be the Gachi holder attributes for this token ID. And then this metadata is going to be, this information is going to be all in one big string, and it's going to contain the values of the happiness, hunger, and enrichment, which currently are not strings. So we need to stringify, convert them to strings before we do anything else. So string memory, and we will say string happiness equals strings.toString Gachi attributes happiness. Thank you, Copilot. And then we'll also need hunger and enrichment. That part's the easy part. Cool. So we've got these things, and now we're going to create the JSON blob that we need to put into our URI for this token. Okay, so it's going to be string memory, and I'm just going to call it JSON, not Derulo. String, and it's going to be ABI encoded or encode packed. Okay, because we're going to be combining a bunch of strings. Okay, yeah, no, Copilot is really good most of the time. Occasionally, like it'll get this won't be here or something, and you just trust it a little too much, and then things don't work, and like all your code looks right, and it compiles just fine, and you're just frustrated as all get out. And I can hear Copilot in the background laughing at me. So we need a few things here, and so this is where this is the start of a string, the single quote. The double quote is going to actually be included in that string. So we'll have our name with the double quote. And then, I don't know, we can call this your little emoji friend. And we'll have a comma and a single quote and a comma. So that's one line, okay? So what we have here is we have the start of our string that we're packing, and then we have some quotes inside the string that are not like denoting strings in this string, but once it's in packed, there'll be strings. The end result is like these will have quotes around them. We have a comma to separate the values, and then we have a comma to separate the strings that we're packing together with ABI encode packed. Okay. This is why this is like the hardest part. It's really easy, but like it's ridiculous. And then we're going to need another single quote, a double quote, the description for our item. Description. Did I spell that right? I think I did. And then say something like keep your friend happy. Cool. A comma, single quote, a comma. Seems like you all have some questions, but you are answering them. Yeah, I think we're good. If they're not, just like, spam it once or twice more, and I will see that. And then, so we have our name, our description. We're going to need the image. So this is going to be that image URI. So we have a single quote, a quote, image, double quote, colon, a space, a double quote, then a single quote and a comma. Okay, so we're opening a string here that's going to be that SVG string. And then we're going to grab the image URI and combine it in there. And then we're going to close it out. Copilot's saving here. So we have a single quote, double quote. This double quote closes out the image URI. Whew, a comma, and then a quote, and then a comma because we're combining more strings here. And then we need the traits. Traits are going to be those values like happiness, hunger, and enrichment. So we have a single quote, a double quote, traits, a double quote, a colon, and then this is going to be an array, not an object. So we have an array, a single quote, a comma, and our traits are going to be trait type. Oops, see, as I almost missed a quote there. And we'll call this first one hunger. And we'll say its value is that string hunger. And then we need to close it. Cool. Yes, it is solidity. Absolutely. And then we're going to need happiness. Now here is where Copilot is coming in clutch, I think. I'm trusting that we're getting all of the single quote, double quotes, it all looks good, single quote, happiness. And finally, we'll close that one. One more, enrichment. We'll close that one. And then we need to, I think this is backwards because I think it's, yes, this needs to be just a, oh no, that's right. That's right. Yeah. So we close that up. I'm pretty sure this is good. Yeah, sorry, y'all. If you're just joining, 100%, it looks like I'm hard coding JSON because I'm hard coding some of the JSON, but also inserting in some dynamic pieces here. This JSON is going to be the URI for our NFT token. So we're creating an NFT Emojigachi, and unfortunately, y'all, oh, he's dead again. Should we feed him? Maybe we should feed him. So I click feed him. Is my wallet locked? Is that what's going on here? Yep. Always make sure you put your mouse up here when you type in your MetaMask password so that the Fox doesn't watch you type your password. It's just a pro tip. You don't want that Fox knowing what your password is. So we're building out this Emojigachi. You'll see it comes back to life here in a minute. Cool. So, whew, okay, I'm pretty sure that we have all of these correct. What else do we need? So we've got the URI. Oh yeah. The last thing we need is we need to return this JSON blob. If we don't return this, it's going to be really sad because then this token URI function won't do anything. I think it's here. Yeah, return JSON. Okay. I think that we're ready to finally get to our test where we needed to build this function. You remember this test? Like I kind of forgot that we were writing tests, but like test-driven development, like this test said go far and we did. Okay, so we need to build out that function. We'll call it Gachi stats. Where do we want to put that? We'll just keep adding to the bottom here. Function Gachi stats. And yeah, we'll take it and give it a token ID. Sure thing. Why not? This needs way more stuff here though, because it's going to be public and it's going to be a view and it's going to returns. What's it going to return? So this is going to return, if we look at our test, what did we need? We need happiness, hunger, enrichment, and checked. And then a string for the image, right? So uint, 4 uints and a string. Uint, string, memory. Okie dokie. At this point, our test should fail differently because we've actually created the function. Oh no, line 96. I think it's this guy. Oh my goodness, y'all. What is going on? So we've got our attributes. So we've got an open parent or curly there, close curly there, return JSON. Something to do here. Encode packed is there. Do we need another one here? I think we need another one here. And then I don't think we need this curly here. Is that right? Yeah, we didn't have a curly. That's what it was. Yes. Okay. Then we're getting an error on line 39 about Gachi holder attributes. Back up here in our safe mint. What is going on with that? So we have Gachi holder attributes for our token ID is Gachi. Man. Silly. Gachi attributes, not Gachi holder attributes. Is this the one that I literally said that Copilot will add in a word like holder and you'll think it's right and everything looks good and it's not? I think it was. I predicted the future. Okay, and then here's that error message. I left it out here just to kind of show you. I forget who asked it. I'm sorry. But when you're asking about the memory, you need to tell it where to hold it. So on line 38, we do need to add that in there. At this point, what are we doing now? Man, test-driven development. Argument named image does not match on line 41. Here, image shouldn't be image, should be image URI. Again, all the tabs from Copilot. Cool. Our test fails. As expected. So we have our test for Gachi stats failing because we don't return anything. But our test is now failing instead of giving us that error of like, hey, we don't have anything to run. So that's good. It's failing better. Fail better. That's my new motto for life. Fail better. So we need to return here a few things. So we pass in the token ID. We need to return our Gachi holder attributes for the token ID. So we need happiness. Yep. I need to make sure I get this order correct. So it's happiness, hunger, enrichment, checked image. HHEC. So we need our happiness, hunger, enrichment, last checked, and the image. And these are Gachi holder attributes for the token ID, and we're passing in the token ID. I think we should be good now. If we run the test, it's not good. I added one too many curly boys. Maybe not enough curly boys. What happened here? Return. No, I definitely need that one. Oh, you know what? Semicolons. They're not a full colon, but they're very important. Whew. Okay. That test was a doozy. I don't know what y'all think, but man, I think this is the hardest part right here. I don't know. But yeah, okay, so sweet. We have our Emojigachi up and running. It is setting the URI. It's returning those. I want to take this one level further so we can test the stats for an emoji that we define, but I'd also like to make a copy, whoops, not of everything, I'd also like to make a copy of this that tests just my emoji, right? So if I run this, I want to test, we'll call it my gotchi. This way it asks who's calling this and gives back the stats for that user's emoji. So instead of emoji stats or gotchi stats, sorry, we'll call it my gotchi. And we don't need to pass in an index now. So this should just run based on who's calling this and return the same stuff. We want to just check and make sure that works. So if we run this, we should fail because we don't have my gotchi. But let's go ahead and add it. So function my gotchi. It's like it can hear me and it knows what I'm thinking. Public view returns. What's it going to return? A uint, a uint, 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 string. Yeah. And then that's not right. It was so close. Let's see. So what we want to do here is we want to return the gotchi stats. This is going to be that function that we just called or created for gotchi holders and the message sender. So this will say run this function for the ID that's returned from the mapping gotchi holders based on who's calling this. Sweet. So let's save it and run our test again. Uh-oh. You know what? See, look at this. Function. Test it. Sweet. That test was easy and fast. I like it. We need more tests like that, y'all. This other one, I don't know who came up with that gotchi stats test. That dude's insane. Okay, so we've got our emoji. We can see which one, like my Emojigachi. I can get that information. How are we feeling? Are we tracking so far? Everybody good? Hanging in there? Hopefully. Okay, let's keep going. We go back to our test. Let's take a look here. So we tested the URI. We now need to test past time. So function test past time. I like it. Cool. We'll call past time. Seems good. We're going to pass in an ID for the NFT that we want time to pass for. It may seem odd that different NFTs could have time pass differently, but we just need to be able to call it individually because if say that we want it to only update once a day, for example, when that happens during the day will depend on when the NFT was last checked and when it was minted. So we're going to pass in the ID of the NFT that we want to check for. We need to grab basically this same set of things here. So we can run it for MyGotchi, or I think probably it would be better to ensure that we are testing the 0-1. Dude, Tippy, congrats. Congrats. How's it going? Is it the last test, the one that we were just on with the Gotchi stats, I hope? So we're going to grab happiness, hunger, enrichment, last checked, and we're going to grab them from Gotchi stats. And then we want to, what do we want to do here? So when time passes, we want to decrease the happiness, or sorry, the hunger and the enrichment by 10 is what I'm doing. You could do whatever you wanted, right? If you had like a very needy Emojigachi and you know, if you didn't play with it, it's like happiness or enrichment, sorry, its enrichment would decrease by 30, 40. I don't know. If you had the world's hungriest Emojigachi and like, you know, every time time passes, it gets 50% of its hunger appears, something like that. You can play with this, make it whatever you want. I'm going to keep it easy and say every time time passes, those values decrease by 10. So we'll do that assert equal. Remember, this comes from that library framework that Foundry provides, the DS test. And what do we want to assert is equal? Well, hunger, once time has passed once, should be 90. We should also say enrichment will be 90. And then just to make sure that we are calculating happiness correctly and that time is passing correctly. So happiness is, remember, it's hunger plus enrichment divided by 2. But just to make sure, we'll say happiness, and then it knows it's hunger plus enrichment. But we're going to hard code these values in because we know what we want. And we're not going to use checked. So we're just going to delete the fact that we're assigning it to a variable and leave it out. So you've got kind of this dangling comma business. So essentially in your mind, you can say checked is here, but we're not using it. And the image is here, but we're not using it. So we've got this test. Sweet. We run our tests. We don't have a function pass time. Let's add a function called pass time. A function pass time. Look at that, man. It's on point. Now, this might work. It could work. But it feels kind of mean to me. When our gachi is dead, to keep subtracting it. And it seems weird to subtract a number from a integer that's unsigned. So we can't go less than 0. That seems bad. So let's throw in a little bit of a test here. So we'll say something like if gachi holder attributes hunger is greater than equal to 10. And this needs parentheses around it because that would be a shame. If it's greater than or equal to 10, then we want to say gachi holder attributes token ID. What do we add out here? Hunger minus equals 10. Right. So we can check if that works. Seems good. Might be better to spell it out a little more specifically, but I think this will work. And we'll do the same thing for enrichment. Yeah, Copilot. And that should be all we need to do, right? Because we do these two things, and then we need to set our happiness not to plus equals 10, but we need to set it to the formula that is, what was it? It's gachi holders happiness plus hunger divided by 2. So we have the happiness plus the hunger, divide that by 2, not happiness. This should be, man, Copilot did me dirty. We've got hunger and enrichment. Yes. Hunger and enrichment divided by 2, that'll be our happiness. So we're updating the attributes for this token when time passes. So let's see what happens now if we run this test again. Doesn't like something, past time not found. Oh, you know what? Man, this should be public. Sweet. So our attributes update, but I'm just now realizing I don't have a test for this. Our attributes are updated, right? But the URI itself isn't going to update. So within the smart contract, the attributes, the mapping of that struct for the token, that'll be updated. But then when it comes to the URI, the token URI, so the metadata behind the token, like the values there and the image, those aren't going to be updated. So we need to write another function that updates those. So let's go ahead and do that real quick. We'll say function update URI, and it's going to take in a uint that is the token ID. I normally put an underscore, but we don't want this to be called outside of our contract. We want it to like call itself basically. And when this gets done calculating the pass time, we want to call update URI for the token ID. So this function here, we're going to need a little bit of logic in here because we need to now use that array of emojis that we created way back a while ago. This now is in play, right? We were just like everything's super happy all the time, but now things can change because we're passing time. Let's head back down and let's think about this. So we have super happy, pretty happy, not so happy, angry, and dead. We have 5 different values. The edges are basically when everything's 100, when happiness is 100, we're super happy. And when happiness is 0, we're dead. So we're going to need 3 different values. In my mind, I'll just break those into thirds, right? So if it's less than 100 but greater than 66, we're the first one. 33 to 66, we're the second one. I think that should work out. So let's build that out. So we need a string. And we're going to use the emoji, call it B64. This is going to be the one value from that array. We'll kind of default it to 0. So super happy. And then we'll say if the Gachi holder attributes for the token ID, I wish you'd like partial complete this, dot happiness equals 100, right? So if he is super duper happy, then we'll go ahead and set it to 0. Else, if it's, let's say, greater than or equal to, we say we're splitting it into thirds. So we can say actually greater than 66. Then we'll set it to 1. Cool. And if it's greater than 33, we'll set it to 2. And if it's greater than 0, we'll set it to 3. Otherwise, we'll set it to 4. Sweet. This is one of those cases where, man, Copilot, I think it worked out, right? Am I missing something here? Anybody catching a mistake? I think it looks good. So this will update the emoji base 64, so that last bit. And then we also need to combine that with the SVG. So we need that string, and we'll take the base, add on this value that we just set, pack that into the string. Then we need to set the image URI to that string for this emoji or gachi, I don't know. And then one last thing, we'll call this set token URI for the token ID. We'll pass in the token URI of the token ID to actually update the URI for the NFT, which is the name of this function. Sweet. How are we doing? We still tracking? That was a bit. How are we feeling? Just checking in. Anything I can explain more? All right. There's probably some delay, but if you have questions, pop them into the chat. We've got past time working. We need to test feeding our Emojigachi. There's a lot. I agree, it was a lot. I can go back through it real quick if that'll help. So when time passes, which is what we're testing, we take the attributes for the specific token that we're interacting with, and we double check that we can decrease them by 10. I'm defaulting to 10 here. So we look at both these attributes and we say, are they greater than or equal to 10? If they are, that means we can decrease them. Cool. Then we recalculate happiness as well. and we update our token URI. Updating the URI, that's kind of the complex bit because we want the emoji to change. So we set it to the first emoji, right? This emoji base 64, that is one of these values from this array of strings. So it's this first one. Somebody mentioned something like the matrix. It's just like the matrix. I see KQT, and I know that's the smiling emoji with star eyes. YGT is just a really happy emoji. SGD, that's clearly a skull and crossbones. Not really, I just know what they are. So we set it to this first value. That's our default. Then we say, if it's 100, we'll go ahead and just set it again. It's not going to change. Otherwise, is it greater than 66? So is the happiness greater than 66? If it is, we go to that kind of happy smiley face, the next option in that array. If it's greater than 33, we go to the next option. As long as it's greater than 0, he'll have kind of the red angry smiley face. Maybe not smiley because he's angry. Otherwise, it's not greater than 0. That means it has to be 0. Our Emojigachi has famished and become so bored. He's bored to death. And we set it to the skull and crossbones. So this is just which string value is held in this variable. We then combine the base from the SVG. If we head back to the top, that's going to be the super long string that we created towards the beginning of this. We take that base and we just smash it together with the emoji ending that we just picked based on our if statement here. Then we're going to go ahead and update the Gachi holder attributes for our token, specifically the image URI. And finally, once we've done that, we're going to set the token URI. This is part of that Open Zeppelin contract for our token ID to the token URI for our token ID. And remember, this function is that crazy one that we did with all of the quotes, the JSON blob here, right? So that's going to return the JSON blob. So we're setting the token URI to the JSON blob based on all the different attributes for our specific token. Hopefully that helps clarify things. Might be clear as mud. I'm not sure. Rewatching might help too, like you said. Okay, so we need to test feeding. So in order to test feeding, first we need our Emojigachi to be hungry. How does he get hungry? Well, we need to pass time. We know that works because we just tested it. Cool. So we need to pass time, and then we need to feed him. Now, we could feed a specific one here, or we could use that MyGachi function, and the message are similar to the MyGachi function. We could use this message sender to grab the ID of our Emojigachi so that we can just say feed. I think that might work. And then because we're just looking at feed, we only care about happiness and hunger. We do not care about enrichment. We do not care about last checked, and we do not care about the image currently. So we're just testing those two things. And so we'll say eg.mygachi. And we want to assert that hunger is now 100 because we fed him, right? Time passed, it would be 90. We feed him, it goes back up to 100. And then we want to assert that happiness is equal to hunger plus enrichment. He's going to be a little bored, so it's going to be 90. Run our test again. Fail as expected. We need to add a feed function. Function feed. We don't want to take in a token ID though, right? Because we want to use the same principle as MyGachi, where we use the message sender, because I don't want other people feeding my Emojigachi. We'll need to grab our token ID based on the Gachi holders, message sender. And then we'll need to set the Gachi holder attributes to, I'm just going to set it to 100, equals 100. We'll need to recalculate the happiness level, because he's going to not be hungry, but he is going to have a little bit of enrichment. There's a question, why is hunger increasing? I may have done things backwards. In my mind, it makes sense for like his hunger is full, like he's full. So he's at 100, and then it kind of decreases as it goes down. Maybe we should have renamed this satiety. I don't know. But in my mind, like when he's fed, his hunger's at 100 and it decreases down to 0. When both the things are 0, then no more Emojigachi. So we're doing happiness here. And that's going to be equal to our awesome formula of Gachi holder attributes for the token ID hunger plus enrichment divided by 2. Weird formatting, Copilot, but seems good. Cool. And then we'll need to use that update URI again, because maybe his emoji changed. And his stats certainly have changed. So we'll call update URI for our token ID. We should be good to go. Let's run our test and see. Sweet. Test feed passes. GM, how's it going? For those of you just joining, we're building an Emojigachi. This one's dead. Seems bad. Let's feed him. Bring him back to life. Maybe. Clicky. We'll check on him in 1 second. So we feed him. We need to also test play. Playing and feeding are basically the same thing. This is going to be play. And this will be play. We don't care about hunger, but we do care about enrichment this time. And we care about happiness again. And I don't know, I think of it as hunger plus enrichment. So I'll go ahead and switch these. I'm gonna make one difference in the test. Run our test, failing as expected because we don't have a play. We are so close to being done with this Emojigachi, y'all. Just a couple more things to go. We'll need to copy this and change this from feed to play. And instead of hunger, it's going to be enrichment. That should be all we need to do there. Run our test. Play works as well. Amazing. That one was fast. The last thing that we could test would be the image URI. But I think just kind of based on time, I'm going to skip that test for now. It's just adding a test. The URI, we know it's updating. I have faith. So we need to make this contract keeper compatible. That's the next step. If we head on over to the documentation, docs.chain.link, you can find automating contracts documentation and keeper compatible contracts. 2 things to be a keeper compatible contract. Check upkeep and perform upkeep. Check upkeep is going to tell us if we need to perform upkeep. We can grab this example contract right here. And I'll go ahead and I'm just going to kind of fast forward through how to test this really quick, but I'm going to start by putting this function into our contract. Both those functions, actually. So we have a check upkeep function, and we have a perform upkeep function. This example is going to be based upon updating a counter. That's what it was doing. We don't want to do that. We'll need to pass time here. And we're going to pass time. I'm going to hard code it to that 1 value. So we've got these 2 things. We've put them in here. We added a tiny bit, but before we get going too much further, I got to stay with the test driven development. And y'all, this is a cool part. I don't know if you're aware, but there's a new movie, Doctor Strange. And Doctor Strange has this really cool relic called the Eye of Agamotto that lets him control time. Forge and Foundry also lets you control time. You can have cheat codes for real life. What does that look like? If we head back to the documentation, in here, look around for cheat codes. What's this? Cheat codes for real life? Why, yes, it is. Cheat codes will let you do things like bend time. You can warp reality. So let's add that in real quick. We'll need to create an interface for our cheat codes here. So interface cheat codes, and we're going to create a function called warp from the cheat codes. And then we'll need to also use them within our contract. So we have cheat codes. We call it cheats. And this will allow us to use this warp function to change time. So we're within our tests. Let's head back down here. We're going to test check upkeep. So test check upkeep. And what we want to do within here is we need to first add in a couple of things. So we're going to have bytes, memory data. This is just because we need to pass in an empty data string into our check upkeep function. We're going to have a Boolean for upkeep needed. We're going to set it to false by default. And then we're going to get upkeep needed. And it'll return data, but we don't really need the data, but we have to pass in data. And we're going to assert true that we don't need upkeep now. So upkeep needed is false. Then we're going to warp time. We're going to warp time by the current block timestamp plus, and we'll just go 100 seconds into the future. Y'all, I wouldn't do too far into the future. The future is a very scary place. Be very careful how far into the future you go. It's, yeah, that's all I'll say about that. Can't share too much information, sworn to secrecy, but make sure you don't warp too far into the future. Then we're going to assert true that upkeep is needed. Before we do that, we need to grab upkeep again. Okay. We need to close our function, save it, should be good to go. Oh, we did already close our, no, that's the contract. What are we complaining about down here? What's going on? That's that guy. Ah, there we go. So semicolons. We'll check upkeep. Essentially, we want to make sure that our upkeep is going to be based on the block's last timestamp or current timestamp of the block minus the last time that we checked. Is that greater than our interval? Our interval, I'm going to set this to 60. You could set it to a variable and like maybe when you deploy the contract, assign it there. I'm just going to hard code it to 60, which would be 60 seconds. That means every 60 seconds, roughly, we'll be doing upkeep. We also need to grab this last timestamp. So that'll be a uint last timestamp, and that's going to be Gachi holder attributes for, I'm just going to force it to 0 last checked. So I'm hard coding in here. If we were using this for like a real emoji project, and there was going to be a bunch of emoji NFTs, we'd probably want to have some way of iterating through these, but just for the sake of simplicity here, I'm only going to mint one NFT, and that's going to be for me. And yeah, you can mint your own if you're following along. So based on this, then we'll check that. And one other thing, we don't need to do anything when our emoji is dead, right? Because upkeep, all it does is pass time. And all pass time does is make it more hungry and more bored. And I'm pretty sure if you're dead, you can't get any more bored or hungry. Maybe you can. I don't know. I guess we'll find out at one point. Maybe this is why you don't go into the future too far. But yeah. So we need to add one more check here to say that both the block timestamp has changed. And what do I want to do here? I want to put this in some prints. And I want to say, and I want to say that, what is it? The emoji holder attributes for 0. So this Gotchi holder attributes. Holder attributes for 0. So close. Dot happiness is greater than 0. Cool. So we'll have our block timestamp. I don't think I actually need this parenthesis in here. Good, still good. So our block timestamp, make sure that time has passed, and then also that we're not dead. Or I guess our emoji's not dead. Hopefully we're not dead too. This will tell us if we need upkeep. Cool. So we can test our upkeep now. And we've got an error. Last timestamp. What's going on? Last. Do we spell something wrong? 212. Oh, it's down here, man. Okay. So we're going to do the same check down here. So we'll need to grab this. So let me just comment this out for now. We don't care about that one just yet. Cert is spelled wrong. Huzzah! So our test upkeep works as well. And then finally, the last test. We are like this close to deploying a contract. And then we get to build the front end. So we now need to check perform upkeep. We can do that multiple ways, or I think probably the best way is just kind of copy this, right? Because we're going to use the same basic stuff here. Function test perform upkeep. You close it. Whoops. Cool. We've got this. Our upkeep needed. We don't really care about that. What we really care about, this is kind of a weird in between where we need to make sure that upkeep needed is true. And when upkeep needed is true, that's when it'll go through this. So we don't need to check the upkeep. We don't need to do that. What we need to do is we need to warp the block timestamp, right? So we need to go into the future a little bit from when we minted this. And then once we go into the future, we need to perform upkeep. And this again checks that time has passed. And what perform upkeep does is it essentially does the same thing as past time, right? So it's going to be all of this that we're checking, except we're not going to manually pass time. We're going to have upkeep do that for us. So this should work out for us. It failed because we commented it out, right? So let's go ahead and uncomment this. And we need to, so when we do perform upkeep, check upkeep just returns a Boolean and it can return other information, but it lets us know, do we need to do perform upkeep? Really recommended. Check upkeep is free. It's a view. You can run it, no gas fee. Perform upkeep makes a change to the blockchain. There's going to be a gas fee associated with it. So we recommend before you do that, you check again. Do we really need to perform this upkeep, right? What if between check upkeep and perform upkeep being run, something else happened and we don't need to perform it anymore? So we want to run this exact same test again. So we will copy and paste. And so we get our last timestamp, and then we're going to use this piece here in our if statement and get rid of this upkeep needed. And there we go. So if the time has been more than 60 seconds and our happiness is greater than 0, then we're going to update the last timestamp to the block timestamp. That's not what we need. What we really need here is this thing to be updated, the last checked. So Gachi holder attributes last checked is now equal to the block timestamp. And then we're going to pass time. Run our test again. Awesome. We have all 8 tests passing. Now, I don't have a test for this, but I know there's one other thing that we're going to need, and that is an event. An event is essentially something that the blockchain emits when certain actions happen to notify people who are listening. And our front end is going to listen for those events. That's how it knows. Like when we watch this, it updates by itself, right? Like keepers update the smart contract, but then when the smart contract updates, our web app also updates because it's listening for those events. So we need to add an event to our contract. I'm going to call it emoji updated. I'm going to come back all the way up to the top. I'm going to put it right here underneath this struct, an event, and we'll call it emoji updated. And this is going to basically emit out a uint for the happiness, hunger, enrichment. Sure, we'll do last checked. Let's just call this checked. The URI, here we'll just call this URI. I'm just trying to keep it as simple as possible. And then maybe the index too. Okay, so these values are what the event will emit. We also need a function to emit those values, emit that event, and tell it what the actual values for the event that are being emitted are. So the reason I'm making a function for this is because I'm going to use it in 3 different places. I'm going to use it in the feed function, the play function, and the pass time function. And so instead of writing out this code, all of those places, I'm just going to write it once. Yes, calling perform upkeep will require gas. What happens when validation fails and we don't pass time? So if you're not making a change, the gas won't be there like that. It won't be as bad. It may be 0. I'm not sure. That's a good question. So emit update. And then we're going to take in, the token ID. And I think I'm going to call this just internal. I don't want anybody else to be able to call this. And we will emit our, is emoji updated. And then this has within it fighting between Copilot and VS Code trying to help me out. So Gachi holder attributes, token ID. So we have the happiness, the hunger, the enrichment, last checked, image URI, and then the token ID. This needs a comma. Okay, so this now we need to add to play. So once we update the URI, then we're going to call emit update for that token ID. Same thing for feed. And finally, pass time. Excuse me. So all of these will then emit that. And now, while I didn't write a test for it, we can check that our tests are passing. And one other thing about Foundry is if I do this and I say I want it to be slightly more verbose with VV, we won't see anything here. If I had a log, you can emit logs with Foundry. You would see it there. But if I add two more Vs, all the Vs, it's going to give us all the data when it's running these. And we can see in here that when we did our test for Emojigachi Play, it emitted this event emoji update. And here's the values that it emitted. And you can see here, we have our data, our image URI is right here. And once again, just to make sure, a sanity check. If we take this and we go to a new tab, and we paste in, hey, he's pretty happy. Unlike this one, he is not happy. Cool. Our contract is donezo. We are good to go. Whew. We need to deploy this contract in the GitHub repo. There is so many files. Deploy script. This is set up for Mumbai. Honestly, looking at this, it could be set up for anything. I'm going to use Alchemy to grab a RPC URL. So we need to run deploy. We need that RPC URL. If you don't have a Alchemy account, you go to alchemy.com and grab one. You'll need to create an account, and then you can create different apps. These are going to be RPC URLs. They basically let you connect to the blockchain. They're kind of like an on-ramp for that. I'm going to use this one. I'm going to view my key, but I'm not going to do that over here because that's private and I don't want you all to see it, even though you're fine people. So I will go ahead and do that on my other screen. I'll copy that key. It's going to be the whole URL. So like the HTTPS, Polygon, Mumbai, everything like that. I'll come back here and I am pasting it in. You can't see it. And what is the name of the contract we want to deploy? Emojigachi. And compile it. And now it's going to ask me for my private key because I am deploying this. So how would I find that? I come to MetaMask. I go here. I go to account details. I click on this button right here, but not where y'all can see. Don't ever let anybody see this. Super, super secret. So I will do that again off screen. It'll take me just a moment. I don't know why it's making me nervous. It's up over there. I'll grab my private key. I'll paste that in here as well. Then we'll wait just a second. Copy and paste something else so it's out of my paste buffer. That would be embarrassing, doxing yourself and giving away your private key on stream. Cool. So this forge create deploys our contract using the RPC URL that we provided above. This is just a real simple shell script. It compiles it, it deploys it, it tells you where it's deployed to. We have this awesome address here. If we, I bet my secret is safe with you, just like all my ETH would be too when you took it. Gives us the contract URL. Our contract is deployed. And I'm realizing now there was one step I skipped. Man, how embarrassing. I didn't mint an NFT during contract creation. Let me go add that in and we'll just deploy this one more time. I really feel bad when I deploy stuff over and over to testnets, but I guess that's what they're there for. So in our constructor, I'm just going to call SafeMint, and I'm going to call it to message.cinder, which is going to be me when I deploy it. And then we'll go through this whole song and dance the same. Freddie, it is a test wallet. There is nothing in that wallet other than test ETH. But I don't know if you ever had faucets dry up on you. It can be bad. Like this account, if we want to go look, I am but a poor boy. So We need to deploy it one more time. I added this safe mint here. So when the contract is first called, it will mint one NFT to me. And off we go. So let's do this whole thing one more time. Always makes me nervous. Plus the fact, you should always just practice safe practices. So Emojigachi. Recompiled it because we did make a slight change. We'll go and grab my private key one last time. I should probably just save it to my desktop, right, chat? I mean, that would make life a lot easier. Bad idea. Don't do that. Okay. Deployed to this address again. And if we head back to here, we'll take a look for this contract. Oh, sometimes it takes a minute. We can tell it's deployed here. We'll give it just a minute. While we wait, if we head to testnets.opensea.io, might be able to see little dude. He's not here either yet. It's going to take a minute. There he is. Okay, so this contract was created. When it was created, we can also see that there was one token transferred to me. It's an Emojigachi. Whoop, whoop. There it is on OpenSea now. But OpenSea doesn't have a picture of it yet. We'll give it a moment. Sometimes things take a second. Okay. Now we've deployed our contract. We've got it going. We don't have keepers enabled yet. So chat, do we go keepers or do we go front end? We'll do the other one here in a moment, but which one do we do first? Anybody want to pick? Anybody can pick. Keepers first. Okay. Keepers first. It is. We had to keepers and oh man. Sorry, Evan. Shaman beat you to it. We had to keepers.chain.link. We're going to say register a new upkeep. One thing to note, this was deployed to Polygon. I am on the Polygon network with my MetaMask on Mumbai. Register a new upkeep. When you register an upkeep, you will need link. If you don't have link, you can get it at faucets.chain.link. You'll need to input a few things. You'll need your email address. Why do you need your email address? So if your keeper runs out of link, we can email you and let you know, hey, your keeper is not going to be working because it doesn't have any link. We'll call this emoji upkeep. We need the address of the contract that we're going to be using. So that's going to be, I'll just grab it from here again, right here. We need that address. It's not going to be able to verify it because we didn't verify it on Polyscan. You can verify your contract where like upload the code. This is kind of just a warning saying, hey, you're setting up an upkeep. We're not sure it's a compatible contract, but we know it's compatible. We have our gas limits. This probably needs to change based on how much it costs to update that. So we'll just go ahead and max this out just to make sure that we can update our thing. And then we'll go ahead and add one whole link to it. That's it for creating an upkeep. So we register the upkeep. It's going to be a transaction. Confirm. Wait for it to go through. While we wait, let's see if OpenSea has a picture for us yet. It doesn't look like it has a picture. Sometimes OpenSea is slow. I find sometimes if I come here, it'll show up. I don't know. Nope. Here's some other ones I made earlier. That's a cool NFT project. Fun little demo I made. More to come on that later. But yeah, so we're just waiting for this guy to get his value popped in there. Our upkeep is registered. Here it is. Our history. You'll see the upkeeps show up in here when they actually run. So the history right now is we just funded that upkeep. Once it needs to run, it'll populate here with like a processed upkeep. Awesome. Upkeep is done. NFT is done. Time for SvelteKit. Take off your Solidity brain. Put in your JavaScript brain. Things are getting crazy. I'm going to warn you right now. My front end skills, they're rough, y'all. My CSS is rudimentary, but it works. So let's get started on the other half of this demo. It's going to go much faster. SvelteKit. This repo, part of the repo, half of the repo, I followed this. I added npm install ethers, and I picked the skeleton project. Not type checked, not TypeScript, just to make life as easy as possible for everybody, mostly myself. And inside SvelteKit, we have the source directory. Inside there, we have routes. This index.svelte, that's where we're going to be starting. So npm run dev will kick off SvelteKit on port 3000. Look at this. It is beautiful. It says welcome to SvelteKit. We can change this to be like GM, and it hot reloads. It's amazing, but we don't want any of this. What do we want? Well, let's see here. We'll call this my Emojigachi. And then we're going to need something here. I don't know, for now, because we said Emojigachi, let's just throw a happy little smiley face in there. Sweet, it's updated. We need to connect our wallet. That's where Ethers comes in. So Svelte's files are broken down into three basic things. We have our script. This is going to be just basic JavaScript. And then you can also, at the bottom, you can have a style. This is going to be basic CSS that's scoped to just this component. And then you have your HTML in the middle. Part of why I like Svelte is it's, I don't know, to me, it just reads nicely and easily. But for this one, we don't need style. We've got enough of that ourselves, right, chat? But we do need to add a wallet connect component. So we're going to import, we'll call it wallet connects from, and then this is a little bit of Svelte magic here. $lib is going to be the lib directory, and we'll import wallet connect.svelte. Connect.svelte. Cool. And then we're going to also create a few props to pass back and forth between things. So I'm going to say export let Web3 props equal, it's going to be an object, it's going to have a provider, and that'll be null to start out with. It's going to have a signer, and that'll be null to start out with. It's going to have an account, and you guessed it, that'll be null to start out with. And then finally, it's going to have a chain ID. That'll also be null to start out with. So we've got these props that will pass back and forth. The other little piece of Svelte magic is this if. This will either show or hide elements from the DOM based on the if statement. So if we have an account, actually, if we don't have an account, then we want to show our wallet connects components, and we want to pass in and bind the values of those Web3 props to this component. So we'll say bind Web3 props. That's, we don't need anything in it. And otherwise else, so if we do have an account, then we're going to show our emoji, right? Seems simple enough. Everything will be terrible and broken because we don't have that component. I just want to double check and see if we've got an image here. Still don't. It's making me nervous. Okay, so everything's broken because we don't have our component. Let's add that. So new file, call it, this is the worst thing about VS Code. When you don't have it active, you can still right click lib and we'll call it wallet connect.svelte. We added the lib directory. Inside there, we have wallet connect.svelte. This will let us set up our wallets and connect it to our application. So we're going to import not wallet connect, silly GitHub Copilot. Ethers. Where are we going to import ethers from? From itself. Seems good. We're going to export let. This is the other like magic thing. This export let with Web3 props, that's essentially what allows you to pass values back and forth between Svelte components. That bind means that like they're going to stay up to date back in the other one on index. Here, this will let us pass them in. So we're going to import or export let Web3 props. And we're going to do the same thing with all of these values for now, just kind of defaulting them to nulls. And then we're going to create a function. Asynchronous, what? Async function connect wallet. And what this will do is this will actually get the information for our wallet and pass it back to our index so that we can go and get our Emojigachi. So we're going to say let provider equal new ethers. Providers dot, what is it, Web3 provider. We're going to grab that from window.ethereum. It needs this extra little value called any. Going to await provider.send. So we're going to send a request to the provider saying, hey, can we get the accounts? Once we do that, we're going to create a couple constants. The signer is going to be the our account. The account, which is going to be the address. And then finally, the chain ID, which is going to be const chain ID equals await signer dot, whoa, get chain ID. Cool. Probably something you would want to do is ensure that you're on the right chain. I think that's like 8001 for Mumbai, something like that. But we aren't going to do that, I don't think. But this is how you get it if you want to do that. And then we're going to update Web3 props to be equal to the, what was the order? Provider, signer, account. Yeah. We'll update the Web3 props and pass in those values so that everything is good there. How do we know if we need this? So let's go down into our actual HTML here. If we don't have an account, that's right, same logic. Then we want to see it's trying to do the thing that it did before. I don't want to do that now. I want a button, and on click of this button, we are going to run this function, connect wallet. And we'll say something like attach wallet. Seems good. Then we'll go ahead and just close out this if. Cool. So we had our component. We passed it in. We built our component. Let's go back and see what we got here. Reading is self-accepting. Something went. Should be signer, yeah? That's what it was. What is going on, chat? Ethers provider, Web3 provider, window to Ethereum, any, that seems good. Provider, new provider, got that in there. Provider send ETH underscore request accounts. That seems good. Signer, get signers, get address, get chain ID, provider signer account, chain ID. All seems good. What is going on? You know, let's just go ahead and maybe when we didn't have this, it borked everything up. Yeah, there we go. Okay. Sometimes a restart fixes everything. So we have our Emojigachi. We need to connect our wallet. I've already connected to localhost in the past, so I'm going to disconnect it so we can see everything work. I click attach wallet. Huzzah! Connect with MetaMask. And we connect. And once we connect, the button goes away and our nice little emoji shows up. So just like that, this is our NFT, right? No, we have a lot more work to do. Not too much. We have a picture yet? Man, nervous for this one. I don't know what's going on. Hopefully I didn't muck up something with the URI. If we did, we can fall back on another contract that's already deployed. Okay, so we connected our wallet. The next thing that we need to do is actually let Svelte and Ethers know about the contract itself. So we're going to need that contract ABI. That's going to be like the application binary interface. It's like an API for the contract. So we're going to create a new folder here, and we'll just call it contracts, even though there's only going to be one. And then we're going to go back to the Foundry directory. In here, under cat or under out, we have our Emojigachi. In this JSON file, this is going to be our ABI. So we're going to copy this JSON file, head back over here, and just pop it right in to our contracts directory. Sweet. So once we do that, then within probably index. Oh, whoa, hey, that's not right. I think that was a auto import business there. Oh, connect. What spelling chat, spelling. Okay, we've got this. We need to now let it know about that ABI. So we need to import Emojigachi ABI from, we'll import it from .. So up1 contracts / emojigachi.json. That'll give us the ABI for it. Also, we need to go ahead and declare a constant for the contract address. And I wonder what that contract is. That's not our contract, I don't think. 9A2, that's our contract. I'm going to be amazed. It wasn't our contract. That would have been amazing. So we have our contract address and the ABI. We need to pass these into Wallet Connect so it can actually grab the full contract and everything we need there. So we're going to add contracts to our Web3 props here. We're going to add the contract address here. We'll pass that in. So we're adding a couple things to our component for Wallet Connect. And then we're also going to say the contract ABI equals Emojigachi ABI. Just kind of keep things simple. We're going to call it contract ABI instead of specifically Emojigachi ABI. Head on over to Wallet Connect. We need to add contract to our props here. Also need to add those two values that we passed in, export let contract address equal, and we'll default it to nothing. And then the ABI, and within this, there's an ABI element or object called null there. So we're just kind of defaulting things. Cool. When we connect now, we get our chain ID. We now need to get the contract. So we'll say const contract equals new ethers.contract. We'll pass in the contract address, the contract ABI, and the signer. And then we'll store this information back in Web3 props. Let's go and double check, make sure everything's working. I attach my wallet. I still see my smiley face. That's good. If I wanted to double check more than just a smiley face, we could do something like here we can say Web3 props dot contract and just see what this gives us. It should give us an object. Yep. And then maybe dot, I think name is one of the pieces of this. Just to see, hey, we're getting information from our contract now. But we don't want this. What do we want? We want our Emojigachi. So we need to build another component. We're probably halfway through the front end. If you're still hanging out, we're getting close. Whew. We need our Gachi components. So we're gonna get rid of our friendly little emoji there, and let's build an Emojigachi component here. Let's see here. Did it import something automatically for us? If I click this button, I don't even know what that did. I don't want to do that. Do that. We're going to import Emojigachi from, I like to use the little $sign because that's svelty. We have our Emojigachi components. We need to make our Emojigachi component. We're doing chat. Are we hanging in there? It's gotten quiet. I know y'all are like Solidity. I know that like the back of my hand. It's front end development. Woof. So here we're just say hi, just to make sure everything is working. I attach my wallet. I don't see anything. Why do I not see anything? Index. If our wallet's connected. Should work. We've put in a component the wrong order. That's why. Cool. We have our hi. So our component is working. Awesome. For front end stuff, I'm glad there's people like you, Shaman. The internet would be terrible if it was all people like me who felt like, as long as it works and it gets the information across, we're good to go. Front end devs make the world a prettier place, and I appreciate that. Okay, so we have our Emojigachi component. We need to, again, we're going to pass in those Web3 props, mostly because we need the contract in order to interact with the contract. So let's go ahead and say export, let's Web3 props. That's right, provider, signer, account, chain ID, and contract. Sweet. Thank you, Copilot. You're amazing. Another little bit of sveltiness. This $: that's going to be a reactive variable. Essentially, that means anytime you're in the actual HTML and you're using this variable, if that variable changes, it's going to say svelte. It's going to be like, hey, I need to update this stuff. And it's going to actually update the page. So we need to have the image, right? So this is going to be all the different things for our Emojigachi. We're going to need the hunger. And I'm going to set them to just kind of some default values here. Happiness, we'll start with enrichment first. So hunger, enrichment, happiness, yes, yes, yes. Those are the values that I think we need for this, right? Because we have the picture, and then we have the 3 different numbers that we care about showing. Cool. Seems good. We can go two ways here. So I think probably we'll start by just kind of stubbing out the actual stuff. So image goes here. We'll deal with that in a separate component in a minute. We have another div, and we're going to say hunger, and our hunger is hunger. Cool. And then our enrichment is enrichment, and our happiness is happiness. Sweet. So these are all going to be defaults for now. We'll use this stuff in a minute. So we've got our Emojigachi. Should be updated here if we attach our wallet. Image goes here. Hunger, enrichment, and happiness. And I mean, I don't know, Shaman. This looks pretty good to me. I mean, it's text, easily readable. I'm proud of myself. This is a nice looking website. We have these items, but we need to actually get them from our Gachi, from the contract. So let's go ahead and get that running now. So we need a const. We're going to say get my Gachi. Right, we're going to get my Gachi. It's an async function. And what this is going to do is say let current Gachi equal awaits Web3 props dot contract dot mygachi. So remember, mygachi, that's the function that returns the Emojigachi of the person who calls it. Cool. So we get our current gachi. And now we can set some things like image equals current. Let me go await these actually. Await current gachi. And then this is going to be weird. Because if we remember mygachi, let's go look at that real quick. So Emojigachi, these are the tests. There is mygachi. So mygachi is going to return basically an array, right? So it returns a uint, a uint, a uint, a uint, and a string. What are these things? So they are happiness, hunger, enrichment, last checked, and image URI. Unfortunately, we can't like create an object and return the object. Unless there may be, I'll put a caveat. I don't know of a way to return a struct with like the object nice. So we're going to be using this like as basically an array. So the first thing it returns is happiness. So we head back to here. We'll wait for image. We'll say happiness equals await current gachi. And then this is going to be the first item. That's happiness. Hunger is going to be the next one, right? So if we go here, it's hunger, happiness, enrichment, and then we want image. So hunger, enrichment is going to be 2. And then this image is going to be not 3, because 3 is the last time it was checked. We're going to skip over 3 and go to 4. Cool. So we get these values from our contract, pulling it off the blockchain. Awesome. One other thing that we need to add here. And do you remember when I said we were going to add in the emit event? We're going to add this emoji updated event, and that would be emitted when things changed. So within our get my gachi here, we're basically going to subscribe to that event. We're going to start listening to that event. And just to make sure, we called it emoji updated. When we see an emoji updated, async, we're going to essentially do the same thing that we just did. So we can literally take the current gachi on. We're just going to do the same thing. We're just going to update all these values. Whoops. I feel like something's wrong here. It didn't auto format. It looks right though. I don't see any red squigglies. Oh, red squiggly here. Why? Const get my gachi equals async. Why is it complaining about this? Closing them down here. Closing here. This one talks to that one. Semicolon. Where's it at? Close your statement. I'm lost, Chad. I'm lost. Shaman, I wish you were here. You could just point at my screen. So get my gotchi equals async, open brackets, this, that. This goes to there. So that one's closed. Let current gotchi equal await. You edit it now. I don't know. Okay. Is something up here? Am I missing something up here? No, all these look good. We got our semicolons up here. These are all happy, right? Yeah, yeah. If I delete this, like if I just cut this out real quick, definitely that. What is in here? My gotchi. Await. Got our semicolons. Oh, well, I know another problem that we'll need to fix. Could it be this one? So this order is correct, right? We close that and then we close that. Spelled wrong. Async. Thank you, Shaman. There we go. Man, this is little things. Am I right? Okay. One other problem. We need to, yes, thank you, Shaman and Gabriel. It was green. I mean, green means good, right? I don't know. So one other problem, these are going to be like big numbers. They're going to be nasty. They're not going to be what we want. So we need to convert them to numbers. So to number on them here, 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 as well as here, here, and here. This will just let us use them a little more appropriately. So let's see if this changed things. Oh, Sean, that was a close one, man. Oof. Attach the wallet. What's going on? Image goes here. Everything is 0. Seems bad. Chat. I feel like something might be wrong. But before we panic, let's go look at this and see our keeper has been slowly killing our Emojigachi. And so nothing changed here, but these are the correct values. Our keeper's been murdering our Emojigachi this entire time, and we didn't even know it. So it's dead. We need some buttons to get this thing back to life. But before we do, let's go ahead and fix image goes here. We are so close. Like, I don't know. I feel like there's a marathon, and I am excited for this. So we need a new thing. Let's just call this face.svelte. Let's put a face to our Emojigachi. And I don't know. We'll just pick something. Yeah, this one looks amazing. Let's do that for now so that we can get it thrown in here. So instead of image goes here, we're going to say this is now, what do we call it? We call it face. And we need to import face from lib.space. Cool. We have our face there. It's looking good. It's looking good. Now our face is going to take in a image value. So we need our scripts tag here. And we're going to say export let image. And then we need to just make our image. So we're going to say image, and the source is going to be equal to the image. Our alt text can be your Emojigachi. Awesome. Just like that. Okay, back here, we're not passing in that thing. So it's going to be a broken image now with the alt tag showing because we didn't pass in our image. So close. Let's pass in image. This is where y'all are about to see my front end dev skills and design work. Refresh, attach our wallets. Uh-oh. What's going on? What's going on? Image. It should be good. We called it image. Am I goofing something? I might be goofing something. Spelled the same here. Spelled the same here. Get nervous now, chat. Getting so close, and we don't have an image here. I'm starting to wonder if I botched something in the actual contract itself for the image piece for that URI. That may be the case. All this for not chat. We have our contract is right. Yeah. Contract is right. It's working. Upkeep is firing. That's good. I don't know what's going on here. Let's console log this image out. Or let's just see what image is real quick. Image isn't coming back as anything. Interesting. So it's not actually updating. Oh, man. It's not the data URI. You see how this is not like a nice bright green? It's because we never actually got Magachi. I was pretty sure that they should be zeros. But we need to call Magachi. At this point, should work. Why is it not working now? In promise, could not read properties of null reading Magachi. Get Magachi. Something's up. Something's up. It's something super simple. Web3. Is this all? Yeah, that's the same. No typos there. Let's go ahead and kill this and restart it one more time. Doing it live, y'all. Magachi. We published that, right? That's what it was called. We checked that here. Magachi. Public view. Yeah. Troubleshooting live. So contract, get Magachi. This is where it's having its problem. Let's go ahead and just throw contract out there real quick. Here, before we do this. Oh, Web3 props.contract. Fun part, right? Testing, figuring out what is going on. Okay, so that contract is null. When we come here, we don't pass in Web3 props. That's the problem. We need to bind it. I don't know if we need to bind it or not. Are we changing anything with that? I don't think we need to bind this. I think we can just pass it in as is. Nothing should be changing. We'll just leave it fine for now. Okay, we'll try one more time. Hey, okay. Crisis averted. Look at this beautiful dead Emojigachi. Here's the actual image. We can take that out of the logging of our Emojigachi. Get rid of that. Get rid of this. And here we go. The world's most amazing CSS. Style. Got a little style tag down here. We're going to say every div in here. You know what we're going to do? We're going to say width, 33%. Yeah, that's right. Now, it's nice. You can see our full emoji with his hunger, enrichment, and happiness of dead. A couple more things. So close. I appreciate all of y'all sticking with me. We are like this close, but we can't play with our Emojigachi yet. We need to add a couple of buttons. Before we do buttons, though, in the original one, we had a little bar, right? So this little bar, we need to add that too. I don't know. I like that little component. Let's add that in real quick. So let's go back here and we'll make one more component called bar.svelte. You impressed with my UI skills? I hope you are. Set the bar high saying that you are a UX designer. Tried my best. No, I'm just keeping it simple for this, but we'll call it status. Yeah, we'll call it status. So we're going to pass in a number, call it status. We're going to have a div. The class is going to be status. And then the style is going to be dynamic based on that status, where we say the width of the bar is going to be whatever the status is %. So based on the number that's passed in, so like if it's 50 out of 100, it'll be 50% wide, and then sure. And then we're going to style this bar real quick. Dot status, and we're going to say not this. We're going to say the height is something like 8 pixels. It'd be a huge bar if it was 100 pixels. The background, let's make it blue. Just something easy. And the width, again, we'll say this is 33%. And we will close that. So this little bar component, we can now use that within our Emojigachi component. So underneath hunger, we'll add a break in there, and then we'll go ahead and have our bar. We'll bind the status to hunger. We need to import bar. So this should give us that bar, but it's going to be empty, but you can see its little spot right here. We're gonna do the same thing for the other ones. So for hunger, we had that one here. We're gonna add a BR, and we're gonna add a bar, status of enrichment. Copilot's coming in clutch, and happiness. So we've got all those. Now we need to add one more final piece, and that is a button to hunger. So I guess maybe underneath the bar, we'll add a button element, and we'll say on click. Yeah, we are so close. And here we're going to say web3 props dot contract, and it knows. Web3 props dot contract. What's going on here? Point to this, and we need this. Does that fix our little underliney business? On click equals open point, open that feed. Why are we complaining? Button on colon click. Oh, equals. Cool. We got our close there. We need 2 closes. I think we need 2 closes. Yes. Cool. And then, so that was feed for hunger. And finally, the last thing, we need a button on click, play, Close. Oh no, this formatting is weird. Cool. So we've got a play button and a feed button. Does it work? If we click the button, it prompts us to do something. It says we're going to run a feed. We confirm. Then we wait. Is it going to work? Drum roll. I need like a drum roll sound effect. See if it works. It may take a moment. We subscribe to it. Should show up. Hopefully. Oh, hey! Sorry if that was really loud. I was excited. Look at him. He got fed. And now we can play with him because he's not dead. It would have been weird to play with him while he's dead. I don't know. Seems inappropriate. But we fed him. We'll play with him. And the keepers will keep passing time. Look at that. Time already passed. Oh, man. Can I beat the keepers? See if we can get him to have star eyes. And yes. So we built an NFT that is on chain 100%. Hey, and it's emoji that you can play with. Like literally the NFT is the game. Super meta. Let's see if OpenSea, what is going on here? Picked him up yet. Man, I don't know what's going on with OpenSea. OpenSea doesn't like him. But our front end likes him, and our front end automatically updates. It's none of this crazy refresh metadata stuff that OpenSea does because it's caching everything. But yeah, we've got it here. We can play with him. Keepers will keep knocking him down, eventually killing him. Yeah, I don't know. That wraps up the demo, the walkthrough, the workshop, whatever you want to call it. I'll hang out for a few more minutes. If you have questions, pop them in the chat. There is a survey that I would love for you to fill out, kind of letting me know how I did, letting me know what you would like to see differently, anything like that. That's the link in the chat. Just for completeness, we have the link to the GitHub as well as my Twitter. If you want to pop on Twitter and say hi, ask questions, show me your Emojigachi, whatever, I'm here for it. The DMs are open. I like chatting with people. Y'all have been awesome. Thanks for the kind words. I really appreciate it. Yes, Gabriel. OpenSea. Sometimes OpenSea is fast and the demo gods smile upon me and everything is great. Other times OpenSea takes a very long time. So yeah, I don't know. Questions, comments, thoughts, let me know. I appreciate it. And I'll hang out for just a couple more minutes before I drop off in case there are any questions. 2 hours and 38 minutes. Woo. Fun stuff. Star Wars Legos. Oh, and Tracer. Yeah, I don't know. The Lego game. There's a giant Harry Potter one up there too, but yeah. I don't know. Legos are an addiction, man. They're how do you do the original encoding for the SVG? So that one is demoing that out real quick is going to be tricky because it's going to be a similar problem to, well, is it a lion? I'm wondering if I can do this quick. Let's see if we can do this real quick. I'm gonna like time box it to like 5 minutes. Function code. And does Avogachis use keepers? I know for sure they use VRF. I'm not 100% on keepers. It's very possible. Encode whatever SVG, and this is going to take in nothing, and it's going to be public. Okay, so this is going to need the Open Zeppelin contract imported. So import at Open Zeppelin contracts utils not ownable. What's it called? Base 64. Base 64. All right. And then I think I'm going to need to say this is also base 4. Maybe I'm shooting from the hip here, y'all. We'll see. We'll see if this works. This could be the worst part of the demo. So here we need the value from the copy pasta. No, it wasn't copy pasta. I had it up here. So we've got our SVG. Yo. So our SVG, this is a string. SVG equals that nasty. Oh no, that's not going to work. Oh no. I don't know if this will work this way. Okay, cool. So inside the SVG, we're using single ticks. I had to make sure because we're back to like that JSON blob business with like the tick game, like single and double quote ticks. Oh, thank you, Shaman. Like I'm talking away here, just showing my face. Y'all can't see like, enhance like the reflection of the screen in my eyeball or something. I saw that in like some sort of crime movie once where there's like enhance. Maybe it was Super Troopers. I don't know. Okay, so we have this SVG string, and then we'll say return SVG. And say we'll just run this in a test. Function test SVG is going to be public. And here we're going to say emits log. Is it? Log. No. It's underneath DS test. So we need to emit a log string, right? That's what we want. Okay, so emit log. And then we'll just say eg dot, we call it encode SVG. Okay. Encode SVG. Let's see what happens here. So forge test, not so many. Did we fail? Oh no. Invalid characters in string. No. I think it's the emoji. I think you have to do something different for the emoji. Because it's not like plain text characters and it's gonna barf on that. So I'm not gonna be able to cover that, but like we'll go old school here. Yeah, maybe that guy. That's a good, classic emoji. Let's see if that fixes it. If this doesn't fix it. Parse error, function, variable, struct, or modifier declaration expected. 121. Cool. Thank you, Snowy. Close your brackets there. Still complaining. Oh, storage. Okay. We're getting closer, y'all. We're getting closer. String memory. Okay, it's not base 64. To the open Zeppelin docs. Speed running. Learn docs. Contracts. Base. Hills. And then from here, did it expand over here? No, it didn't. Base. Import this. I don't know if we need to make it a base 64. I think that may be okay without this. No, it should. My brain is mush, y'all. How do we use this? for its bytes to its 64. So encode the data. I use open Zeppelin base 64 example base is spelled with an E. This is how we do it, chat. Right here. This is just the actual script itself, yeah. The actual contract itself. Oh, it's a library. Okay, that's why. So we don't need to do this. So save. Invalid type for argument and function call from tuple. What? From tuple. What is going on? With a string, memory. Pass this in here. Do I need to say returns down here? That's what it is. Returns, string. Oh, but it. So yes, Shaman, it's essentially that. You're right on. Get this running. There we go. Setup failed. I'm not sure what's going on now with the test. But yes, Shaman, essentially, you're going to pass in the value in base 64 and code it. Where's a good example of this? Build Space has some tutorials. GitHub, where's their GitHub? It's going to be in here. This is the same project. Contracts, yep, libraries. So this base 64 is the same library that you'll be importing from Open Zeppelin. And then in here, you can import base 64 here. And then, so we have the JSON, right? And they're passing in the JSON instead of already encoding. So they're encoding the entire JSON like metadata blob, the URI blob. But it's basically that same thing where you're going to take a string, turn it into bytes, and this combination would be that SVG. You can see here their base 64 encoding the final SVG right here. So it would be just like this. Does that answer your question, Shaman? And you made an egg-shaped background and wanted to change the background depending on the happiness. I need to see this NFT when you're done with it. You need to tag me on Twitter. Cool. Yeah, if you have any problems, I don't know, just shoot me a DM on Twitter and I can help you out. But yeah, I don't know. Thank you all so much for coming. Thanks for hanging out. I know this is a long one. We're almost at 3 hours. You all are champions for being here, sticking through it, helping me figure out my typos and silly mistakes. So yeah, with that, I'm going to wrap it up and I'll catch y'all later.